So welcome back class 10th students in our chemistry session, in our chemistry class, and the chapter is same, acid, bases and salts. The lecture number is 8, and today we are going to have some concepts on indicators, the types of indicators. The use of indicators is a very small topic, and usually I think all of you must be aware of it. Then we have to get in touch with that pH value. What is pH? So before starting, first of all, I would like to tell you about pH and what is the ionic product of water. These are the things from which I will start. So one by one, the main thing is that pH and the ionic product of water. So you will get the concept one by one, and then you can apply it to the indicators. What are basically the indicators and how it works? So that is more important. So let's start. Now H2O is a weak electrolyte. It dissociates to give H plus and OH minus ion. Now H2O is a weak electrolyte. It gives H plus and OH minus. Now there is a topic, chemical equilibrium. Why I am telling this? This you will study in the 11th class in physical chemistry. So from this chemical equilibrium, this concept is coming, because we have to see that on applying law of mass action. So I am not going into that detail. There is no need to go in detail. What is the result of this? There is a theory, there is a concept, there is a theory on which we get this one. Kw is equal to concentration of H plus into concentration of OH minus, or as it is written, Kw is equal to H plus concentration into OH minus concentration. So this is the way to represent. Both are the way of C stands for concentration and H plus stands for H plus ion. Again C stands for concentration and OH minus stands for OH minus ion. So Kw, or you can by this square bracket, whenever any ion is closed by this square bracket, it means it is representing the concentration. Concentration means moles per volume, amount of moles per volume. That also you will study in the mole concept. That is a very important chapter and very important. So many lot of concepts are there, we will see there. So whenever there is inverted comma, square brackets, then we have this, it represents the concentration. So Kw is equal to H plus into OH minus, or you can represent it. Now H, and in chemistry, whenever you find this K, mind it, this K is a constant. In chemistry, in physical chemistry, in chemistry, you will find so many K's, and all K's are always constant. Mind it, this is very important fact. So this Kw is constant. So in water it was found that that this value takes up as like this 10 to the power minus 7 into 10 to the power minus 7. Therefore Kw is equal to 10 to the power minus 14. What does it mean, dear students? Means this is fixed. The product of the concentration of hydrogen ions and the product of the concentration of OH minus hydroxyl ions is fixed. That is Kw is equal to 10 to the power minus 14 into pure water, in pure water. So this is Kw, and this is known as the ionic product of water. This is known as the ionic product of water. So this is about a pure water. Now what happens? What happens? See, listen very carefully. When any acid is being added to water, as we do, so what is basically happening there? The H plus ion concentration increases, right? Or when any base is added, the OH minus ion concentration increases. Now this is the product, that Kw is equal to H plus into OH minus, concentration of H plus into OH minus. Now when in any acid, when any acid is added to water, if this H plus ion concentration increases, listen me carefully, it increases and this Kw is constant, so which has to decrease to maintain this OH minus ion concentration will decrease. Or opposite to it, when any base is added to water, so what will increase? This OH minus ion concentration will increase, and to maintain this K as a constant, this H plus ion concentration will decrease. So this is about the Kw and H plus and OH minus in pure water, and what happens. So we can easily, when H plus ion concentration is correct, by applying indicators or by going to the pH value, we can test whether it is an acid or base. So next topic I am going to take is about, let you know about what is pH, then we will come to indicators. Now we will discuss about pH. So what is pH? It's basically a scale. A scale for what? To scale to test the acidity, you can say, or the basicity of any solution. How? By testing or by calculating the H plus ion concentration, or even in 11th you will see POH is the word. Calculating the POH means calculating the OH minus ion concentration, but here we are only confined to pH. That is, so what is the pH means? pH. pH is a German, it's originated from German word, and it means that power. It represents the power. So what is basically pH? pH. Power of what? Power of hydrogen ions. So basically it was found that pH is equal to minus to the logarithm base 10 and the concentration of H plus. So pH, you can say minus log base 10 CH plus ion, both ways. Means here the C is representing for concentration, as I told you just now, and these square brackets also represent the concentration, and these concentrations are in moles per liter. Mole you will study, then you will get, means concentration. As you study, a simple thing I would like to tell you, as you study density, mass per unit volume. In solids you study now, in gases you study mass per unit volume. Similarly we have in solutions. The density, you can say the density is here called as the concentration. Means amount present per liter, moles per liter. So that is the concentration. That represents the strength of any acid, strength of any base. How? By calculating the H plus ion, because the any acid, what it signifies or what it represents, the whatever the H plus ion or hydronium H3O plus ion, the characters of all H3O plus ion or H plus ion is the characteristic property, show the characteristic property of that particular acid. So this pH is equal to minus log 10 CH plus. So now being a mathematics student, you can easily calculate what is pH. So for neutral it is basically 7 and then 7 to 14 and before, so it ranges from 0 to 7, 7 to 14. So suppose if we have, for example, if concentration ion is given like that, 10 to the power minus 7, 10 to the power minus 8. Concentration of H plus ion is 10 to the power minus 8. So what will the pH? So pH will be simply, pH is equal to minus log, you apply the formula, and the concentration is 10 to the power minus 8 to 10 to the power minus 8. So this will is equal to minus into, you know the log m to the power minus n is equal to minus n log m, so minus 1, यहाँ वाला minus into minus 8 log 10 base 10. So minus into minus 8 into this is 1, so it comes to pH comes to 8. So this way you can, by applying mathematical concepts, you can calculate the pH, right? So and the scale you are knowing, it ranges from 0 to 7, 7 to 14. So this is the all about pH. Now dear students, we will study about indicators and apply this there. What is the use of pH? So we have just studied about pH. So pH ranges, as I told you, ranges from 0 to 7 to 14. So 7 pH is, that particular solution or compound is neutral. 0 to 7 acidic, above 7 basic or alkaline. So this is very common. Now indicators. What are indicators? Indicators, those indicate about what? Whether particular compound or solution is acidic or not. Now dear students, I would like to tell you about the concept of indicator, how it works, because in your book it is very well given that litmus changes from this to this, methyl orange changes from this to this for acid, for alkaline, then phenolphthalein changes from this to this, and we have a very good chart there, and from which range to which range it changes, which range to it abruptly changes, what is the difference between acid base indicator and what universal indicator, how is universal indicator helpful than acid base indicator. All the information are given very well and in a very good manner and in a sequential manner. So you must go to all the diagrams there and the table, it's very well given. Now how indicator works, that is important, that I have to tell you. That indicators are actually weak organic substance. Weak organic substance, or weak means weak organic substance means weak natural substance, natural occurring substance, as in the case of litmus, or either they are weak acid or weak base. Weak acid means the H plus ion concentration, the dissociation of weak acid is quite less, and in weak base the dissociation of OH minus is. Now how it works, let us see. And if you remember when I was telling you about periodic table, so I compared that Na is a neutral atom and it changes to Na plus ion. Then I gave you example of chlorine is a neutral and it changes to chlorine anion. So I have given the properties. So you must have noticed that Na, on being in a natural state, in its atom state, it is colorless, but when it changes to its ion, it has some color, as the same case is with the chlorine also. And in analytical chemistry, in practical, you must have also seen, we analyze the cations by their color. Fe2 plus dirty green precipitate, Fe3 plus reddish brown precipitate, and so on. So what is the here concept? When these weak acid, weak bases ionize, mean from molecule to changes to ion part, then there is a slight change in the color, and when an acid is mixed or base is mixed, so accordingly H plus ion and OH minus ion increases or decreases. So there is a change in the color due to that formation of ions, or due to the increase or decrease of ion or addition of particularly acid or base, whatever the requirement is there, whatever the condition is there. So this change in the concentration of ions led us to indicate through the color whether it is an acid or whether it is an base. So dear students, this is how an indicator works. How we come to know by indicator that this color is changing to this color, so it is an acid. This color is changing to this color, so this is, because when any molecule, again I am repeating, when any molecule changes to any ion, due to the color of the ion, there is a change in the color of the solution. Therefore we are able to know whether it is a particular acid or base or whatever range we are having. So indicators, very well we know common acid base indicators and universal indicators. So we have common acid base indicators. All of you must know this litmus paper or litmus solution in ethyl orange of phenolphthalein. Then we have universal indicators, that they are dyes in fact, and they are having advantages over this acid base indicator. So let us see, I have drawn the table, let us go through it and just have a look. Now dear students, we have to study two things in indicators, or better saying that you have to cram these two things. First is determination of pH by indicators, which is given in your book, and then color change by indicators in both, in acid base and in universal indicators, and determination of pH. This is very important topic and you have to cram it. So I have just, what I want to say, this is from your book only, determination of pH of indicators, and I hope it's nothing to explain it. You can easily go through it. We have common base indicator, then we have the pH range 1 to 7 and 8 to 14, and then we have litmus methyl phenolphthalein. Now this is the range before 3 to 4 methyl orange changes, litmus changes from 5 to 7 before that, and then it gives red for acid and for base it gives blue. Then we have methyl orange, yellow, phenolphthalein colorless, changes from here with this value range phenolphthalein. Then we have universal indicators. यहाँ पे क्या कॉन्सेप्ट लगा है, विबग्योर, उल्टा चलोगे जो रेनबो कलर है विबग्योर, विबग्योर रेनबो कलर से इसको याद करने में आसानी रहेगी, ये ट्रिक से याद कर सकते हो, इधर से गया, एंड इसमें आपको यू हैव टू क्राइम इट, violet indicator, blue, green, yellow, and this is universal. Universal indicators has advantages over because it tells the strength of the, it can tell the strength of the acid and bases, but here we cannot tell because it abruptly changes, अचानक ही change, and it gradually there is a change in color in this gradually. Then after that in the next page you have color changes by indicators. In by acid base की पर्पल है तो रेड से ब्लू हुआ, तो कलरलेस है तो मिथाइल ऑरेंज क्या हुआ, तो फिनॉप्थलीन क्या, तो वो सब याद करना पड़ेगा, एंड यू हैव टू क्रैम, दैट इज वेरी इंपॉर्टेंट. सो आई होप द कॉन्सेप्ट पार्ट आई हैव टोल्ड यू, एंड डियर स्टूडेंट प्लीज गो थ्रू इट एंड स्टडी एंड लर्न बाय हार्ट. नाउ दिस इज ऑल अबाउट द इंडिकेटर्स एंड द pH, and this is for today's lecture. That's all about today's lecture, and next we will start the salt, the last topic. We have to study about the salt and the formation of salt, different types of salt and formation of salt. So that's all for today. Thank you very much.